Welcome to today's Master's Class. My name is Jose Rivera. I'm the CEO of CSIA, and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global, non-profit trade association with over 500 member companies in 35 countries. To highlight just a few of CSIA's many member benefits, the CSIA Best Practices Manual guides control system integration companies in the setup and running of a solid company. Any system integration will benefit from the best practices, but earning the CSIA certification is a confirmation by a third party that you have deployed them correctly. For partner members, CSIA offers an ecosystem to grow their system integration programs, understand their customers' pain points, monitor industry trends, and share their thought leadership. The Industrial Automation Exchange is a trusted resource of qualified integrators and suppliers. It helps system integrators, industry suppliers, and manufacturers connect and do business. For system integrators and partners, it provides a platform to support your content and search engine optimization marketing efforts. Position your company and C-suite as thought leaders and nurture prospects by providing a credible source for information about your company and its products. Finally, a reminder that in 2021, we will have increased access to knowledge sharing, community building, and networking throughout the year when you join or renew your CSIA membership. CSIA is committed to delivering extremely relevant content to system integrators while providing partner members access to a highly engaged audience. To that end, CSIA will deliver weekly virtual events on a broad range of topics and experiences, all of which are open to sponsorship. For more information about CSIA, membership, virtual events, and sponsorships and advertising opportunities, contact us at info@staff.controlsys.org. And at this time, I would like to introduce Travis Cox from Inductive Automation.
Thank you very much, Jose, and really appreciate the opportunity to be here and to present on today's topic. So I'm Travis Cox. I'm the co-director of sales engineering for Inductive Automation. I've been with Inductive Automation since the very beginning. And currently our team are the solution architect team. So we help customers and partners apply best practices, set up our architectures, and overall help put together various solutions. Today's topic here is really a relevant one, and looking at how we can leverage modern technology to securely open up access to data. All right, so look at today's agenda. I'm going to do a brief introduction to Inductive Automation and to our product Ignition, just a quick introduction there. But for the agenda, I want to talk about why connectivity is so important and looking at the digital transformation journey that people are undergoing and some of the roadblocks that are there to that journey and to connectivity in general. We're going to be focusing a lot about security, and I want to talk about some industrial control system attacks and lessons learned from those. And then really ask the question about how secure do you need to be and what does that look like? We'll look at how legacy systems and architecture has been put together for for the last 20 years and looking then to a more modern architecture, more modern infrastructure that has definitely a security first mindset, looking at various guidelines around that and how we can really get access to more data securely and leverage that data and bring it up to different layers securely as well. And some of the modern encryption protocols and technologies that are available. We'll also take a look at 3 secure examples. So examples of what customers are doing today and how they are leveraging that data and doing more with it, but doing that again from a security first mindset and what that looks like. Of course, throughout the time, if you have any questions, please enter them into the question and answer area, and we can we'll inject questions as they come along if it's relevant to the topic. Otherwise, we'll save time at the end for our Q&A period. So let's get started then. Brief introduction to our company, Inductive Automation. We were founded in 2003, and we are a software company, provide HMI, SCADA, and MES and IoT software. And we were founded by a systems integrator. He was frustrated with the software in the market and ultimately wanted to leverage modern technology, leverage open standards, and set out to build his dream software. Today, we have a highly diversified customer base across many industries. We have a very strong integration program with over 2,200 integrators in that program. And it is Ignition's used by large end users doing, solving a lot of problems, that they have. So if you want to learn more about our company, go visit inductiveautomation.com and go to the About Us section, and you can see more about who we are. Our product Ignition is a software product, it's an industrial application platform. It's a platform to build any kind of HMI, SCADA, MES, and IoT applications. It is unique and has unlimited licensing model. So it gives you unlimited tag screens, clients, projects, device connections, and more. Completely cross-platform, based on IT standard technologies, server client architecture, completely all web managed, and modular configurability to basically kind of set a foundation that you can build onto as you go forward. One thing that's really important to inductive automation is our ecosystem. We have we're really committed to building an ecosystem around a product and around with partnerships to help end users really get the most value and be able to build the solutions that they need. In terms of partnerships are really incredibly important to us, and our partnership with CSIA is really a really important one. As we grow from integration roots, our founder has the integration mindset and really wanted to provide the best solutions, the best tools in the tool belt that integrators can have to provide solutions to their customers so they could flip the whole paradigm where they can offer more to the customers and give them that really that warm fuzzy about the applications that they're providing. Integrators are core to our business. Again, from a partnership standpoint, not only the organization, but with integrators, it is a key part of how we can all transform this industry. We are also a part of various open source projects like Eclipse Milo, which is the OPC UA open source implementation, as well as Eclipse Sparkplug and Tahoe. We'll be talking more about MQTT and Sparkplug here today, but we're part of those groups. And lastly, the Open Process Automation Forum. The OPAF group that was started was to basically get away from one conglomerate system and looking at leveraging an open standard that is adopted widely by everybody so that we can have interoperability and security and connectivity and making building solutions easier where we can leverage best-in-class products. We are certainly part of that forum and looking forward to the outcomes of that, and we'll adjust our product to make sure that we're meeting the industry norms and standards as we go forward. Okay, so let's dive into today's topic. First of all, why is connectivity so important? To me, connectivity is really key. We look at that in our personal lives. We're completely connected at all times, right? Through social media, through news outlets, through our mobile phones and tablets, and having Amazon Echo in our house or various things. Where it allows us to connect people and processes together, right? And connectivity in industrial world is very, very important to have, and something that is now becoming more commonplace, right? But hasn't been that way historically. But it allows us to really look at getting remote access. We can stay connected during emergencies, especially during the pandemic like that we're going through. It allows end users to basically, get connected, stay connected, especially if they're working from home. We have today this always on mentality, right? And I can tell you personally, for me, as I've been working from home, it seems like I'm, working more, and there's more going on. And that mentality of where I could just pull up my phone, get the data that I need, do what I need to do, that is a really important one. And the technologies that are available to allow us to take advantage of that, to be able to really get access and get the benefits that are there from getting access, from speed to just the flexibility of being able to see it, and the agility and being able to help others, in collaborations, as well as all the cost savings and ROI that we can receive. So connectivity is really key, but there are definitely roadblocks that we've had to connectivity in the industrial world in particular, from legacy and proprietary software communications, from very restrictive licensing models that makes it very cost prohibitive to bring data or to bring information to more people. Difficulty in deploying applications, especially ones that do not leverage modern technology, can be tied to specific operating systems, or even operating systems obsolescence is a real issue that we have. The fact that a lot of things aren't standards based or leveraging IT standard technologies, kind of bridging that gap between OT and IT. So rather than doing that, it's more of a divide that's been out there. The fact that we're not using the latest technology, and I think most importantly, that people are resistant to change. And this has been a roadblock in, for kind of that digital transformation, really get into that next step. But, I really like this particular graphic here, this cartoon, because, and it really paints a perfect picture of sort of where we've been, right? And that the industrial world's kind of a little bit behind, and we definitely want to get up to those times, but we say, digital transformation is years away. We don't have to see our company changing anytime soon. We got the time to think about it. But then here, COVID happened, and basically this having to work from home, and it really made us look. It was a catalyst for the change that we're seeing in the industry, and the shift that is, okay, these projects are really important. We got to make sure that holistically we're all agreeing and moving forward to, to our digital transformation journey, and to, in particular, getting access to more information out there. So I just think is really relevant, cartoon here that to the times that we're in. Now, there's a lot of demands that we have today. And looking at this, I mean, that catalyst of change, right? There's a lot of enterprises, there's a lot of things they'd like to have. They have an increased demand for data. They want to bring in everything, eliminate all the silos of data, get data at faster rates. We want to increase data access. We want to have operations and the business side get access to that data. We want remote access, and as well as mobility to leverage that on premise or remotely. We want to connect systems together and have them be interoperable. We want to turn data into insight by leveraging analytics and machine learning. That's the true Industry 4.0 idea, right? But these are the demands, the things that we want to do with that. But the problem is that we are, stuck into the reality of where we are with industrial, digital transformation, and the reality of what the systems look like today in the OT world. So the proposition is really great. All the benefits, all the amazing ability to leverage analytics, get data to more people. But it really looks simple. But at the end of the day, the reality is that we live in a very complex world. OT data is, there's a lot of legacy domain knowledge that's needed. There's mappings. There's a lot of data that we're not even getting at to. It's a difficult world that we're in. And it's hard to replace some of the technologies that are there, and or very cost prohibitive to do so, or just because there's a lot of proprietary technologies that do exist. So it can make it hard to get to this new world, right? To bridge the data over, and we just realize it's a difficult transition. But the problem is, it's really been a mindset. A lot of the digital transformation projects are driven from IT down, rather than looking at it from an OT first mindset, OT up. So we have to ask ourselves, then how do we meet these demands and open access to data securely, right? Because if we don't have that OT first mindset, and we are trying to bridge OT and IT and be able to kind of hack work, getting data to more places, we can open ourselves up to attacks. And the threats out there are real, right? There's a lot of industrial control system attacks that we've seen in the news. Two in particular that I will cover here today, one being Stuxnet Virus, and the second one being a very recent one of the Oldsmar water treatment plant in Florida. If we look at Stuxnet in particular, I'm sure a lot of you are aware of this. It started in 2010. It was a malicious computer worm, and it was introduced through a USB flash drive. And the idea was that it was brought into on-premise, so this was not, it was an air-gapped system. It was not something that we got from somebody hacking into the system. It was somebody just plugging in a drive, and ultimately it targeted Siemens control systems to basically alter the PLC program. And once it was on that network, it was pretty easy to be able to do that attack, to bring that out. And there's a lot of lessons learned that were from that. In that PLCs can be very vulnerable on an OT network. Air-gapped systems can be compromised. It doesn't mean that, again, we have to be hacked remotely. It could be somebody who is on premise, and people happen to be one of the things we have to protect against when we look at cybersecurity in particular. So this was an important one that we've learned from, as well as the recent one from Oldsmar water treatment plant in Florida. This was an attack that happened just about a month ago, and it targeted a SCADA application, and that was running, and to basically increase change a set point to increase sodium hydroxide to deadly levels. And it was introduced, and they got access to the SCADA system through widely used commercial remote access applications. So where remotely I can, get access to a desktop that is running the SCADA system to be able, to do and perform those changes. So didn't go to the underlying PLC control system, it went to the SCADA system, but they were able to get through there. And the reason for that is because really of shadow IT, right? We have this proprietary technology from that's SCADA that has to be installed on an OT system, and we wanted to get remote access, so we put newer technology on top of it to allow remote access to that workstation. But ultimately, there was a shared password. It was already logged in. It had the ability for it to change set points, all of there, and so it's kind of the perfect storm of various things that allowed this to happen. And ultimately, it's again, I can say kind of shadow IT is that wouldn't have been the way we really want to provide remote access. Would have been this technology, just one that was there, easily accessible. And so we really got to take a look at our systems and how we're putting them together. Another lesson that was learned here is that the SCADA program should have prevented that set point adjustment over a certain delta, right? And putting those fine-grained security and putting those details in the application, it can be challenging to think of those things, but it is really important. We don't just want the system completely open to whatever anybody can do if they get access to that workstation. So it makes us really look at our control systems and look at how they're put together to know, are we opening ourselves up, and or is there a better way that we can attack it? So today, hopefully, what I want to do is give you some guidelines and some understanding of what we can do from a technology standpoint to look at this. So first of all, how secure do you need to be? You might be tempted to think that it's a rhetorical question, but it's absolutely not. Security is not a checkbox you can enable and then rest easy. Security, both IT-based and more specific SCADA security, is deep and a complex topic. There are dozens of different technologies you might choose to employ in the name of security, each with different costs, implementation difficulty, and feature compromises. To make matters worse, we need to acknowledge that nothing is 100% secure. As the Stuxnet attack showed us, if you become a target of a foreign intelligence service or military, no amount of technology will protect you. We can, however, make a successful attack extraordinarily difficult and expensive to pull off. Security is all about risk mitigation. We can't eliminate the risk entirely, but we can certainly reduce it. Sometimes we can transfer risk with concepts like insurance, but at some point, there are some risks we must accept. A good thought exercise is to consider what would happen if a natural disaster hit your facility again, or hit your facility, and there might be ways that we can reduce or transfer that risk, but what we end up is accepting some of it. So what we don't want to do is indulge in security theater also. We don't want to make sure that we are reducing the actual risk we face in the most straightforward way. In the end, in the end, how much risk we're willing to accept ends up being a business decision at the end of the day. So that leads to a lot of the common security issues there are. So the question is kind of, where do you stand with that? Have you audited your systems to date? PLCs certainly can be vulnerable, on the OT network. So we should look at that. There are a lot of systems that have shared passwords or weak passwords, or just simply no password policies at all, and are not using central identity management. There's SCADA systems that don't automatically log out, or they're again logged in with a simple, with weak passwords, and they have no fine-grained security, so they can kind of do whatever within the application. As with the Oldsmar example, these things are out there, and or just lack of modern open standards, especially lack of open, leveraging modern security standards that are very widely, done on the IT side, not so much done on the OT side, and because those issues we have, and the fact that we have outdated OSs or OT systems, it can provide a lot of problems. Along with shadow IT, this is probably one of the bigger things. Again, people putting things in place to make their job easier, but not really coordinating with those efforts with IT and making sure that security is kind of that security first mindset. And there's a lot more, right, that we can go through with that. Now, we've been developing SCADA systems sort of the same way for a long time. I want to first talk about architecture. When we look at solving the challenges that are on the OT side, we got to look at the OT networks first and OT systems and how we can make them secure and be able to change the architecture so that we can deliver data up at higher levels securely, right? If we, again, completely had an air gap system, That is fine. However, it can't happen anymore, right? The digital transformation journey demands more data. So looking at the way we've done it, typically we have our SCADA systems. They'll be connecting directly to those control systems, those PLCs. They're out there. You might have local HMIs out on the floor as well, and you might have people, of course, launching the application from that SCADA system, getting that data. Often these systems are proprietary, or they are stuck on a particular operating system. And those are things we have to look at as we go forward. As well as, we've wanted to bring data to the IT side. And what we see a lot of times is turning SCADA into middleware. That's the source of the data. And ultimately, we need data for maintenance management or other systems or ERP. And we start writing code, getting at that data, doing some ways. And we can get to a place where the systems become brittle. And really, the fundamental problem here with all of this is that we have a coupled architecture. And that's been the way that we've done it for a long time, in that we simply have our applications talking directly to the devices. Or we have software, SCADA software, it's middleware that's not meant to be middleware. That's not what it was designed for. So these kind of architectures are really the first thing we should look at from an OT side of the fence and how we can make that better. But we do have to look at the needs between OT and IT. OT data consists of, as we know, proprietary protocols, multiple data formats. There's no contextual information. We have to do a lot of mapping. There's a lot of legacy domain knowledge. It's designed for operations. It's different across different market segments. It's typically a poll response data retrieval from these devices. We have that directly coupled to applications concept that we typically do. And again, isolated networks that are very commonplace. IT, when you look at those needs, it's just different needs, right? OT's focus on operations, IT's focus on security and business and those kind of applications there. And it needs data objects and modeling. It needs standard data formats, contextual information, decoupled architectures, which typically involve publish subscribe methodologies or enterprise service bus ideas, things that are easy to integrate and, of course, very secure. And so what we need to do is basically be able to make sure that we can combine these two things together, have the best of OT and IT work together as one unit, and be able to solve these challenges from a security standpoint going forward, and how we can leverage that data. And there's sort of a trend happening here. It's called DataOps. It's a methodology that basically allows us to do that data transformation, to connect to all of our OT data, provide a single source of truth, transform the proprietary protocols into proper tags and naming structures, and leveraging open standards to get that data out. Creating tools for building data models, and adding metadata such as scaling engineering units and documentation and much more. And ultimately getting to a place where we can auto-discover the information from different applications. Having a decoupled architecture that will allow consumers to simply connect and learn all the data instantly, of course, with the high degree of security that's there, and deliver that information to the infrastructure, again, with that security first mindset that's there. So this is something that we're looking at, and fundamentally has to happen from the OT side. DataOps trends has got something we have to look at, solving from an architecture standpoint, and then we can start getting into real digital transformation. So what I suggest is implementing an MQTT architecture or a decoupled architecture. We're decoupling applications and devices. So MQTT is a pub sub protocol. I'll get into more details on that and what it provides, but you can see here, applications are not connected directly to devices. Rather, devices publish data into infrastructure, and then multiple applications can consume. So applications don't know the end devices, and devices don't know the end consumers. We're going through a message-oriented middleware that allows us to orchestrate all of this and provide a high level of scalability at the end of the day. And MQTT in particular is an open standard. It is part of the OASIS standards body, and the payload specification called Sparkplug, which is the definition of the data, which OPAF is looking at here as well, is the Eclipse Sparkplug and Tahoe projects. It's open source there as well. But idea of MQTT as message-oriented middleware is a publish and subscribe infrastructure. It was designed for real-time mission-critical SCADA, and it's meant to be very simple, easy to implement on very constrained devices, very efficient. It uses very, very little bandwidth. It's report by exception, so we report data up as it changes. It's an outbound originated connection. So we make a connection up, and there's no ports having to be done on the firewalls locally there. And it's completely open, right? So there's no vendor lock-in, and it's very secure. Security is part of it. It leverages TLS and doesn't define its own security models, as well as it has things like access control lists, things we can leverage to provide a very secure infrastructure. The payload specification called Sparkplug, it defines the OT-centric topic namespace, the data model, the state management. We have to have state, which is why MQTT is used for industrial. We need to know if we're connected to devices and if we can trust the values. Provides the ability to do data, to have metadata, provide the data, objects models that we're talking about, and supports this auto discovery and this single source of truth at the edge, along with being able to have store and forward at the edge. And we'll get into this more detail, but I'll create a parallel. Sparkplug is the payload definition. It's like HTML is to HTTP. Sparkplug is what that is to MQTT as open standards. If you look at what we've been able to do with HTML and HTTP, there's been a lot of innovation. Look at leveraging open standards like Sparkplug and MQTT. Again, a lot of innovation can happen. So real quickly, in terms of the Sparkplug offering those different features, the OT-centric topic namespace is one that's really important to know where the message came from, and it delineates that, provides uniqueness across what edge device, what PLC, and all that it come from, and it has this notion of birth and death certificates so that we know the state of what's happening. We can define assets, models and assets from the edge. So these template definitions where we can, and I'll talk more about that in a moment, but we can know not only just bring up data, but bring up data with context. And it's a very efficient binary encoding of the payload is very small. Uses Google protobufs to compress it as much as possible, along with report by exception. It's very efficient in delivering data. And again, having that state management, we know the state of the system at all times. So let's look at, though, if we're going to leverage this kind of architecture, we do have to really bridge the world between Brownfield and Greenfield, right? In that there's two kinds of OT data. There's lots of OT data out there, but two major categories here, which are brand new smart sensors and devices that have MQTT or various open standards built into them already that we can leverage. And these are being brought into our infrastructure, and we're putting them in parallel along with, of course, our PLC data that typically are leveraging our traditional poll response protocols. So looking at both of these, the new smart sensors and devices that part of the Greenfield world, there's a lot of opportunities, obviously, with that. We can get at more IO out there, especially IO that we didn't bring into PLCs or we just didn't have before, because a lot of these smart sensors are battery powered, they're wireless, they do not need to, we don't need to run conduit or power or anything like that. We can just connect to IO or read additional information and overlay that onto our existing network, right? Very cost effective, very easy to do that. And leveraging things like, and a lot of these devices leverage MQTT directly. It's plug and play, plug it in, publish it up, and we can take advantage of that data. So this is the way that things are going, right? This is where the different technologies are going from an OT side in terms of being able to get at more of that data. And there's a lot of great opportunity, right? All of you could take advantage of that for your customers very easily, and by putting in these new smart sensors to solve various challenges that are out there, where it would have been very cost prohibitive to do it the old way. So great opportunity, but we do live in a brownfield world, right? And we have a lot of PLC data from these poll response protocols, as you can see, things like Allen Bradley, Modbus, Siemens, DMP3, BACnet, all sorts of things, right, that are out there. And the idea is that we want to basically take that OT data, provide that single source of truth, bring it up through using MQTT and Sparkplug to have IT defined data, right, that we can leverage, and not just SCADA, but leverage everywhere else as well. And that single source of truth idea, being able to define data models at the edge, do it one time and have it discoverable at every level above, including if we want to bring that data to the cloud, is really important. And then having all the engineering units and the custom properties and the context that's around that data. And we want to be able to use tools to do all of this. We don't want to write code in places, to do a transformation. We want DataOps to happen, but we want it to do it in a very simple way That's also cost efficient, both on just the fact that of licensing of these products that are doing it, as well as the cost efficient in terms of data, and that we're sending less data, especially over slower connections, maybe cellular connections, satellite connections, or if we're going through things, there's LoRaWAN, there's various things. We want to be able to do that cost effectively, and we want to have a scalable solution at the end of the day. So a lot of times what it comes down to is leveraging edge computing. Edge computing is, really, we're seeing a lot more, response to looking at edge computing and the benefits that are there with it. If we put a embedded PC with software, or if we put a hardware edge computing device out there, whatever it happens to be, we can pull data, especially in the Brownfield world, pull data on these PLCs at the source. We can pull it at faster rates. We can add a layer of protection in front of our PLCs. I'll show an example of this. We can get access to more of that data. We can efficiently provide that data to our infrastructure, and leveraging modern, protocols like MQTT as an example. And at the same time, we can provide store and forward, right? We live in a world that's not perfectly, connectivity is not perfect. So edge computing can provide us that guaranteed does not lose data when the control system couldn't do that. Edge computing can provide that ability for us. Not to mention that when we have it out there at the edge, we can, it's an instance that can allow us to do more compute. Maybe it's simple, just calculations. Maybe it's more of like analytics and machine learning. There's a lot of possibilities that come around with being able to add computing. Now, I would suggest that the first thing is to get data up and solve the data problems, but then, then you can start coming back and then looking at how we can look at compute to solve additional problems, right? So it's all about being able to lay that foundation. Ultimately, edge computing can provide more security. It can also provide more scalability on these systems, especially as the needs of data is becoming a lot bigger, and how we're delivering that data is changing. So I'm going to show you an architecture. Now, this architecture happens to looking at Ignition products. I certainly by no means am as a sales pitch here on Ignition whatsoever. I'm just using as an example. A couple of these examples I'm going to have uses Ignition as an example, but it's to illustrate the point in that I could have an edge gateway out there running on an embedded PC where we can talk to the PLCs locally on a pull response and native protocol, pull that data locally and bring that in and do store and forward as well. But ultimately, I can publish that data up to a central broker. Now that could be on, an MQTT server, could be on premise, could be in the cloud, doesn't matter where you want to put it, but we can deliver that data up securely. So one thing to note is that we are having this extra layer of protection in front of the PLCs, right? We can lock that PLC down to, you can simply dual NIC your embedded PC. You can lock that down, the PLCs behind it. Makes it a lot harder for somebody to get access to that control system, like with the Stuxnet and the USB drive, and provide just more scalability because we're polling at the source right there. Secondly, we can securely send that data up, leveraging TLS and report by exception, it's securely and efficiently delivering that data with state up, to different applications. And then lastly here, we're opening up access to that data, right? So by putting us that server, we can have SCADA not only get access to that central SCADA system, but we can have line of business applications. We can have big data, IT, ERP, maintenance management, CRMs, all sorts of applications tap into that same data. And there's so much power and opportunity that exists when that data is available to more consumers. And having OT and IT working together fundamentally on this infrastructure, and they know sort of what that data flow looks like, they're committed to the same idea, and they're able to leverage it. That's really an important part of the message here today is if security is something that we really have to be thinking about and has to be something that's committed by everybody. Now, one thing I want to mention here is that with all this in digital transformation, there's kind of this perception of having to rip and replace, where I can't get to something new and better without having to replace everything we have out there. And that's a pretty common obstacle. And I would say that, look, it demands looking at this from a different approach. We should be looking at parallel infrastructure alongside existing infrastructure. It's far too hard and cost prohibitive to simply replace everything that's out there. We have systems that are working, and we need to potentially upgrade them because there are vulnerabilities and things like that might be out there. But we can easily transition from an old system to a new IoT infrastructure, and we can get wins as we do that along the way. We can solve real problems by just simply putting a new smart sensor or an edge device in there that can bring data up to an MQTT server and then leverage that data further, but do it in a secure manner. Right, fundamentally putting secure products and secure approaches in from the get-go, not trying to balance the whole proprietary and unsecure world to the secure world, right? Really fundamentally building it into the infrastructure and leveraging open standards and platforms really lets us do that. And there's a lot of cost-effective ways that we can, real simply, we can start putting some of these things in place. So I just want to provide that. You don't need to, as integrators, you could go in and simply look at solving particular challenges and leveraging these newer technologies to do so, but working with their teams on that. Now, along with architecture problems, isolation or air gap systems have been something that's been in OT systems for a long time. In fact, Purdue model, what came to ISO 95, was largely based on being able to segment networks to do it properly, because there's a lot of benefits of segmented networks, and I certainly encourage it. From improved security, because network traffic can be isolated or filtered to prevent access between different network segments. It provides better access control, so they can only access specific things they're allowed to. And improved monitoring, we can see exactly what's happening through these different layers. If there's any malicious behavior, IT is really a good part of monitoring that. We get improved performance, and we get better containment of issues, especially if we wanted to shut down a layer, we could do so, but keep running operations. So segmented networks are really important. Here's an example of what this could all put together as. If you have your layer 3, your OT SCADA systems, or you put smart sensors in there, you have edge devices if you're talking to PLCs, you can have your SCADA system at that layer. That data can easily then, you're providing that locally, those applications in the SCADA realm, we can deliver that data securely again through MQTT to a DMZ, right? So we can bring data up to an MQTT server securely through a DMZ. It's an outbound originated connection, or mode originated, so it's only going up. There's no inbound ports to our OT networks, and we can then have that data there that then other systems from the business side can subscribe to, whether it's another application system, ERP, big data, IT, as we're talking about, right? Real easy way to leverage this data a lot further. So let's talk about the access to the application. We need to be able to see and control our process from anywhere. We want to be on premise, remote, over a VPN connection. We want to be on the plant floor, an office, our home office, when we were remote. We want to be able to get it on any device, right? Doesn't matter what kind of device it is. If it's a PC, a panel PC, smartphone, tablet, smart TV, we want to be able to leverage and get that data. But we have to have a security first mindset, right? Leveraging modern technology and standards and encryption protocols from the application side of it. Not only do we have to deliver data securely and have proper segmented networks, but we have to also look at being able to make the application a secure system as well. Because there's tons of benefits of being able to get data to more people at faster rates. We can provide important KPIs to different parties. The data and control can move with the user. It's not specifically tied down. We can get data to the business side. We can easily push out changes and deploy get faster updates to people. And all of that's going to lead to faster response times, more accountability of everything. So there's great, reasons to have access. But again, we have to make sure we're not just installing remote access software to get access to a desktop that's running an application. We want to fundamentally have remote access be part of the systems that we're putting in place. Now, we also want to look at having modern security practices, a security that we can trust. Tried and true standards, so TLS 1.2, 1.3, HTTPS, that's what all of the applications on the web are actually doing, that we can leverage. We want to have IT be manage certificates and firewalls and be a part of that, and leverage Federated Identity providers. We'll talk more about that in a moment. Have things like automatic session timeouts, and one really important thing is use the principle of least privilege. This is the basis of a user and role management. Only give people access to what they need. Only give machines networking access to what they need to connect to. Don't give users local admin accounts if they don't need it. This can really help contain attack from spreading across network at will, right? And of course, make sure you have systems that have high degree of auditing, so we can see who's getting access, what they're doing, what's actually going on with it. Now, leveraging Federated Identity, this is a great approach today. And on the IT side and the business side, what's being used is that we have corporate identity or central identity management. And these are using industry-leading encryption protocols like OpenID Connect and SAML, systems like PingID, Okta, Duo, ADFS. You can log in through Google and Facebook with this type of system. It's this federated, identity management, and it provides things like single sign-on and multi-factor or two-factor authentication. And I think that's the most important thing, right? In our control systems for so long, we've been putting a shared username and password or weak passwords because we don't want it to be our burden for the operator to get in. But these systems are built with modern technology, and ease of use is part of it, right? That's what single sign-on is there for. And that second form is also to just continue to verify the identity, right? Extra layer of protection. And we can use the existing corporate credentials. It's all supported, managed by IT, and having everything on the business and the operations side leveraging the same management, it leads to much better secure system and infrastructure overall, especially if you want IT to open up access remotely so you can get access to these systems, again, all in a secure way. Another thing that's really been seeing a lot in OT is leveraging HTML5 applications in OT, right? We typically have thick clients that are installed. We need to get to a place where we're leveraging simply browsers or kiosk modes, which are applications running embedded browsers, provide higher security. But ultimately, leveraging that, simply no plugins, all native, and it's much easier for getting access to data out there, especially if we have phones and tablets. We want to be able to harness the power of those devices, get to the GPS and accelerometer and camera, and leverage that as well. Of course, with our application. But the reason it's important is to use this from an OT standpoint is it's an experience everybody's familiar with Microsoft Office 365 or Google Drive or other business applications that they would then be used in the OT world, especially for SCADA. And they have a high level of security, right? Their browsers are the most developed on and pen tested thing in the world. And so we can leverage all of that when building these systems. Of course, it also makes it easy for IT to support. And so we can see that if we have this OT first mindset and having it easy for IT to support, we're talking the same language. Then we can start getting at the root of being able to get data up securely. So a couple of guidelines to really look at here from a security standpoint, and kind of summarize some of the points here, is that we have to ensure everyone is committed to security and trained on the different processes and practices that we're doing. Both within OT and IT. And the successful companies are the ones that are putting an OT manager and IT manager together and running as a single department. And really understanding, like, look, we have to have digital transformation from OT first mindset, bringing it up, but leveraging IT technologies. We got to avoid shadow IT and removable media. You can definitely lock down USB devices on things within your OT networks, and we certainly encourage that. So that we avoid any kinds of, we want to protect those PLCs, right? And leveraging Edge can provide an extra layer as well as benefits of being able to get at more data, faster rates, and have that stored and forward. Having a segmented network, leveraging DMZs, proper firewall rules, remote originated connections makes the moving of data between layers secure. We can guarantee things like that are read-only in those cases. And we also can have secure connections all the way around, right? Leveraging modern encryption protocols. Then if we look at leveraging MQTT to bring data infrastructure, we're not only doing it securely, but we're doing it efficiently to bring data up to those applications. And we want to have applications in our OT side, along with IT, that have security at the forefront, right? We really want to make sure we might have some unsecure systems and we can keep those, putting secure systems in parallel. Ultimately, we want to phase out those unsecure ones. We want to phase out, old operating systems. We want to be able to keep everything up to date. We want to patch these things regularly, and we want to be able to leverage our corporate identity, right, with the security rules and the two-factor authentication that's there, and really auditing, right, a big part of everything. Audit what we have, audit all the connections, what's going on, so that if there was a breach, we'd know what's going on, and it wouldn't be something that, luckily in the Oldsmar case, an operator was looking at the SCADA system and saw that somebody was in there. But if he wasn't there at that point, then it could have been, it may not have been found, and we could have gotten to it could have been a lot worse in those scenarios. So applying best practices, and looking at ways that we can not only provide a better SCADA system and a better operational architecture, and be able to leverage that better on the OT side, but solving that to then get OT data and leverage that data remotely from an application standpoint, and just from being able to use that data more. And I think I'm going to show you a couple examples of how we can use that example more, or use that data more in 3 different ways. First being how companies have been able to access SCADA remotely using VPN, and how we could do that securely. The second one would be accessing it SCADA remotely, but through leveraging the cloud, again, securely. And then third being how we can just leverage our data and bring it up to cloud services and what that could look like. So the first one here is how we can access SCADA remotely using a VPN. So if we have, again, applications that are designed to have remote access, they're, for example, HTML5, then it's very, very easy for, if I'm at home, I can be on my laptop, I can have a secure VPN connection to the business, and IT provides that, those VPN connections, and we can get access to an application, and that's living here in the business side. Now, we don't want them to get access direct to an OT system. That's what whole segmented networks are for. But so we can have all the OT data, delivering data up to the business through MQTT using a DMZ, and then that application can be provided again. That could be willing for remote access, and we could do things like make sure it's read only, no read write, and all of that. We can really lock things down very securely. And so this is a pretty common place we're starting to see a lot of companies leverage this kind of architecture. A second example is going even further is, sometimes VPN connections are not always the easiest thing, and IT doesn't have, some they don't have the ability to set it up. But we want to be able to get data out to people remotely, especially if they're working from home. And how can we do that securely? Well, we can certainly, again, to give data through MQTT, get it to a business system that can then send that data up through MQTT, through a secure TLS tunnel up to the cloud, and leveraging a cloud like AWS or Azure, where an application can be provided there. That is just a secure HTTPS connection for somebody, so it's on the public internet, very secure HTTPS connection to get that data. Again, we can enforce read only and with high degree of security. It's not like that's just going to go all the way down, get to those PLCs. There's a lot of layers and security, protocols and IT approaches that we have here, and IT understands this. And so that's the way we can do this. And we have quite a few customers who didn't have VPNs, but they had data that was on the OT side being published to the cloud, and then leveraging that through an application, easily getting access to it. So, in this, the BPC people using AWS and Azure tools, right? Just getting data up to their brokers, IoT hubs, and using their dashboarding tools, things like that. And that's what my third example really is look, we have this data on OT. If we can securely leverage MQTT and getting data up to higher layers from the edge, for example, we connect all the OT data, we can build our models, build all that we're talking about, deliver data securely, and then we can send that to a cloud. For example, like AWS, I'm not endorsing it here, just an example. We can go to AWS IoT Core, MQTT Broker. There's a bridge that can get that data to a product like IoT Sitewise, which basically builds as assets and models, logs data to a time series database that's highly scalable in the cloud. And they have tools for dashboarding, of course, bringing that data back and doing a lot with it. Could provide not only remote access for data for people, but could provide the ability now to go further with that data. So logging into a time series database over time, we start getting into digital transformation, Industry 4.0, where we look at doing things like analytics and machine learning, and being able to bring those, back into our and get those benefits and bring that back into our systems. So hopefully these three examples here really kind of give you an idea, flavor of some of the things that people are doing out there, but looking at it again from a security first mindset. And I think these guidelines are really the important kind of message today, is that the technologies exist. We certainly have from smart sensors and edge devices, and leveraging product protocols like MQTT. There's a lot of acceptance around that. A lot of products support it. We have a lot of options today, software and hardware options that are available. There's applications you can install that leverage native HTML5, that bring data to people, that leverage modern security practices. I mean, all these things are there. What we got to do is still look at it from our OT first mindset. And that is, so let's solve the operational challenges that are there. Let's get a better architecture. Let's get a better way that we can provide data. We don't want to turn SCADA into middleware. We want to fundamentally get data to the right infrastructure. And we do that, we're starting to really, we're securely moving data. We're getting access to more data, and we're going to get more benefits of it. So there's just a lot of possibilities that are there, and it's great today. I mean, technologies are available that are cost effective, that are easy to put in. We can put it in parallel with our existing systems. In some cases, there are new Greenfield applications. We can just, that's going to be how we start. And it really can start solving some of these problems. Now, always, security is something that we have to be thinking of. As I said before, right, nothing's 100% secure. It's all about risk mitigation. It's about how we can do this the best way and applying the best practices that are out there today. And it's hopefully you got to see some of those best practices from what I was going over here. So let me go back at the end here. That's really the end of the presentation. Hopefully you guys found this to be very beneficial. I know we have 10 minutes left here. Just want to open it up to any questions or comments that happen to be out there, and be happy to address and go further with that.
Okay, thank you, Travis. I'm looking at our Q&A box, and I don't see any questions that have been posted by our participants. So maybe we provide one more minute in case anybody would like to put the question for Travis to answer.
Yeah, and don't be shy. I have a lot of experience working with different people who have been, looking at how to do this successfully and working with it. I know one question that people typically ask from us is around the cloud, and we would never be able leveraging the cloud or even leveraging mobile devices, like having Wi-Fi on premise, that's never gonna come into our facility or our plant. Well, that is certainly a concern. And as I said, one of the big things that are the obstacles is people that are resistant to change, right? And there are certain people that say, look, well, that's just not how we've done it. It's we can't. They're scared of that approach because they're kind of on their own, right? If they're not on their own, if we're looking at have OT and IT working together and have this be a mindset that everybody shares and committed to, then then I think there's more acceptability of being able to leverage these technologies to go further and think about sending some data read-only to the cloud or leveraging Wi-Fi for mobile devices locally. It is certainly approachable. The technologies can make it secure, but you have to have that commitment. You have to have people who want to get there and have that collaboration between different departments, so you can really ultimately get the benefits that are out there. We all see the benefits, but we need to get that collaboration first. So hopefully that bought a little bit of time there for a question, Jose.
Perfect. There was a question that came from Alexander Klein, and it is, how would you suggest approaching companies about IT-OT convergence? I know that there is often friction between these two groups.
Yes, and there definitely is. Historically has been friction between these two groups. So at the end of the day, one thing that's been very successful as I've been working with these with OT groups and IT groups is that, first and foremost, right, they're different. They have different needs. They have different concerns that they're dealing with, and they talk two different languages, right? Ultimately, you have to have some common ground where the two can work together. And there has to be first and foremost some commitment to say, look, okay, we're gonna have some collaboration on it. But IT really needs to realize that the role would be, look, the OT mindset is there. We have to solve those challenges and work with them in collaboration to go further as we look at it. But if we're leveraging things that IT understands, they start opening up more, right? They start saying, oh, okay, I understand that. I can secure that. I know how that works in my environment. The reason the friction's been there for so long is because they're like, well, I don't know what this is. I don't know how to secure it. I'm just going to put it over here in a corner and try to isolate it as much as possible. But then we're just pushing the can down the road, right? We're potentially opening ourselves to vulnerabilities or shadow IT. I would say bring up the example of Oldsmar or various places where shadow IT just simply has opened ourselves up to more issues and pinholes than we want. and saying, look, we don't want this. We want the business has particular needs, and we need to make sure that people are committed to fulfilling those needs on both sides of the fence, and they're working together and collaborating to do so. So when I see that rift, and I basically ask them straight out, like, why aren't we collaborating more? Why aren't we looking at this and realizing that, yeah, we have different needs and requirements, but ultimately the business has things that we need to do. How can we satisfy those business requirements and do that securely at the end of the day? So it's a challenging one, it's a challenging question to look at. But the companies that have been successful, the ones that has a culture mindset, said, look, we're going to make this a commitment, and we're going to have the right people working together. Those are the ones that have really gone a lot further. So definitely, we see that's just that played out. And I think you could bring that up, and really start having those dialogues and conversations at the end of the day.
Thank you. Thank you, Travis. And if you let me share the last slides here, it was a great answer, and I think it was a great question too. Quite honestly, this is a situation that we have had for quite a while, and just like on that cartoon that you had about the wrecking ball in front of the building, of the people pretending that there was nothing that forced them to implement digital transformation. This pandemic has accelerated a lot of things, and I think that those comfortable excuses of like, I'm too concerned about cybersecurity will no longer be valid. These excuses about not collaboration between IT and OT will no longer be valid, and they will be pulled in together to make this thing work. So thank you very much. I want to thank you on behalf of CSIA for this very, very good discussion. And I also would like to thank Inductive Automation for sponsoring this event. And of course, to everybody that attended today's virtual event. I would also like to remind you that the recording will be available for viewing within the next couple of days. Please visit the CSIA website to view past virtual events that you may have missed. And please make sure that you bookmark the following CSIA events. We're going to have next week on the 13th, the CSIA Assembly Town Hall. This is the annual business meeting that we share with our members. It's a members-only event. We will provide an update of how we dealt with the crisis, including financials, and a very important announcement about the 2022 Executive Conference. We also have these other great masterclass presentations coming on the 19th and 26th by Schneider, Aviva, and Festo. So thank you very much. And if you have questions, if you want to reach out to us, you can reach Lisa Richter, our industry director, and here's the information, or you can contact me directly too. I'm the CSIA CEO. This concludes our program today. Once again, thank you for joining us and have a great day.